Hi, welcome back, interested students. So today we did mean and standard deviation of sample means in my last video. And so to review, the mean of a sample mean is um, it's an unbiased estimator, so it should be the same as your population mean, right? And the standard deviation of your sample mean has a formula. It's the population standard deviation divided by root n. N is the sample size. So today we're going to be dealing with sample means and the central limit theorem. Okay, so all right, Dr. Lopez gives students 90 minutes to complete the final exam for her course. Most students use almost all the time allowed, and relatively few students finish early. So the distribution of times that it takes students to finish this exam is strongly skewed to the left. So what does that mean, skewed to the left? That means the people on the left side are screwed. So this is what a skewed left distribution looks like, okay? Strongly skewed to the left because very few people finish the test early. Most of them finish right at the very end, right? So the distribution of time that takes to, okay, so the mean and the standard deviation of the finishing times are 85 and 10. So they tell you that the mean, right, is 85 and standard deviation is 10. So this is what the population looks like, right? It's skewed left distribution with a mean of 85, standard deviation of 10. So how would you write that? It's be like this, right? Mean is 85, standard deviation is 10. Okay, so suppose we took a random sample of 40 students. Now is 40 a lot? 40 is actually a lot. Enough, because as long as it's greater equals to 30, right? If it passed 30, then we can assume that the sampling distribution is going to be approximately normal, right? Okay, even though the population is skewed left, but because the sample size is 40, which is greater equals to 30, right? 30 is just a number, right? If it's more than 30, as long as the sample is large enough. How large? More than 30. And calculate the x bar as the sample mean finishing time. We can assume that the students in each sample are independent. What will be the shape of the sampling distribution of x bar? Like I said, so n equals to sample size equals to 40, which is above 30, and we can safely assume that the sampling distribution will be approximately normal, right? It's approximately normal. Okay, so it says even though the population distribution of the times is skewed left, the sample size is large. How large? It's greater equals to 30. So the sampling distribution of x bar won't be skewed, right? It will be, um, I was actually reading the wrong one. The sample size is large, right? How large? N equals to 40, greater equals to 30, right? Greater than or equals to 30. So the sampling distribution of X bar will be approximately normal, even though the population was skewed left. Okay, next question here. The ages of the 175 players in the youth hockey league have the following distribution. So, very few young kids, mostly between 12 and 13, right here, close to 13, but it's skewed to the left, right? Can you see that this is skewed left? Because, in my mind, people here are screwed. That's why it's skewed left, right? On the left hand side. So, suppose that we were to take a random sample of 10 players. So the sample size is 10, not very big, 10, right, from this population, and calculate the sample mean of the population, or sample mean age of the players in each sample. What will be the shape of the sampling distribution of the sample mean? Now, here, because the population is skewed left, if we had a bigger sample, like more than 30, we will be able to assume that the sampling distribution of the sample mean is approximately normal. But we now can't do that because the sample size is only 10. So if the sample size is only 10, do you think that the population, the shape of the sampling distribution will also be skewed to the left? Well, it should be, but I know we do not have enough information to determine the shape. Yeah, it should be skewed to the left, right? If your population, the shape of the sampling distribution of the sample mean will match the shape of the parent, right, which is your population, right? Since the sample size is small. So, for example, if your parents are very tall, well, the kids are typically also tall, right? So um, the shape of the sampling distribution will match the shape of the parent, given that the sample size is small. But if the sample size was big, if it's bigger than 30, then the shape of the sampling distribution will be approximately normal, regardless of the shape of the parent population. Okay, although it will be closer to normal than the parent population is. Okay, so one more, right? A certain type of golf ball is tested by a robot that hits the ball with a consistent impact force. The distances this type of ball travels in this test are normally distributed. Okay, it tells you that the population is normally distributed with a mean of 195. Okay, I can write it this way. If the population is already normal, right, I can put an N, and then I can put this symbol 195. The first number is typically the mean, and the standard deviation of 5. So this is how we write a normal distribution. Put an N, and then this squiggly line, and then parenthesis 195. The first number, it indicates the mean, and the second number indicates the standard deviation. Suppose that the quality control experts regularly collect random samples of 25 distance measurements and calculate the sample mean distance in each sample. Assume that the measurements in each samples are independent. What will be the shape of the sampling distribution of the sample mean? So since the population is already normally distributed, your sampling distribution should also be approximately normal, right? Should be approximately normal. What does it say? Since the population is normally distributed, the sampling distribution of the sample mean will also be normally distributed, even though the sample size is small. The sample size here is only 25. Now, if this was greater than 30, well, it's going to be normal either way. But since this is less than 30, you might question, ooh, what would be the shape of the sampling distribution? But fear not, because you were told that the population is already normally distributed. Therefore, the sampling distribution should also be approximately normal, right, as indicated here. So if you have any questions, please let me know. Good luck.